it had a part B, and we just ignored part B until we were done part A. So part B asks how many grams of ammonium are produced in the above reaction. So we're going to use that same given value of 50 grams. So in this case, our balanced chemical equation stays the same. The given of 50 grams of nitrogen and its molar mass that we can recall stay the same. The only thing that's changed is what they are requiring. So in this case, we've got the same balanced chemical equation, so we're done. We've got the same given in its molar mass. We are now requiring the mass of ammonium. So now we're comparing nitrogen and ammonium and ignoring hydrogen. So this is quite handy. And if you will notice, I've erased it, but you're basically just redoing the same thing. So I'm going to walk you through the same steps, but if you're doing this, you could notice before you've erased your steps that you've already done part of it. So you don't really have to redo it, but you might want to rewrite it for step B without doing the equation. So we know we've got 50 grams. We already solved for our moles. We already know this is 1.8 moles. So we've gotten that far. We know that information from doing part A. We don't have to redo it, but we do have to pay attention once we get to this heart of our problem solving, because we've changed our required. That means we've changed our molar ratio. All right, so now we are needing to find ammonium. So it is 2 NH3s. All right, we're starting from nitrogen to every 1 nitrogen. So now it is 1.8 times 2 divided by 1, and we're going to end up with 3.6, oops, that's not a 6, 3.6 moles of our required, which is the NH3. And again, they want the mass back, so we're going up here. All right, so we are going to take that same route again, going this way, going this way, going this way. All right, so we need to use the molar mass, though, of ammonium this time. So we are going to multiply by the 17 grams per mole. That's the molar mass of ammonia, 3.6 times 17, and we're going to end up with 61.2 grams of NH3. And again, do your therefore statement, because it shows that you know what you started with and what you finished with, and you can identify that 61.2 is in grams, and then it applies to ammonia. So you want your therefore statements to include all that information. So that's how we solve that part A and part B. That's how we extract the information given from those problems. All right, so let's take a look at another problem. And again, if you're feeling confident, you're like, I can follow through all this, you can stop this video and just go and solve problems. But if you want to see the walkthrough, then stick with me. Make sure everything is erased. All right, so next problem. This has 4 parts. We're going to solve A, and we're simply going to look at B, C, and D. All right, so Part A says, propane can undergo the following combustion reaction to form carbon dioxide and water. And it's given us the combustion reaction, and you don't need to wonder if we're going to be tricky. We're not. If there are no numbers out front indicating the number of particles, then check if it's balanced or not, because that might not be stated whether it's a balanced or unbalanced equation. If you don't see any of those coefficients out front, then wonder if it's balanced and check. But if you do see coefficients, we're not going to be tricky and put the wrong ones. So if you see coefficients, the equation is balanced. All right, and for this part of the course, we are just going to ignore that they're gas, liquid, solid. It doesn't matter at this point. It will matter later. So if 3 molecules of propane is combusted, all right, so we've got 3 molecules of that is combusted. That means it's reacting with oxygen. How many molecules of CO2 are formed? So that's part A. So again, we've got to do all of our steps. So step 1, we already have our balanced chemical equation. You want to pull that out of the equation. You want to write it out so that you've got it separate from all the words. All right, and then take a look at your given. We've been given 3 molecules of propane, and we have required is our molecules of CO2. So what have we got? Do we need our molar mass of the given? We can figure it out, but if we take a look, we're going from molecules to molecules. We're never going to need the mass root, so we don't need our molar masses. But you might want to just put this in as a reminder that you can figure that out if you need it in parts B, C, or D. So that could be information that you can get, but don't waste your time if the question doesn't need it. So it doesn't need you to figure out the molar mass. Don't do it. We will need Avogadro's number because we're working in molecules and particles. All right, so let's get going and solve that part A. All right, so we have 3 molecules of our given. Okay, and let's identify our root. We can go from moles. We need to go through the heart of it and get back to particles. All right, so 3 molecules. I'm not going to write out the whole number, but to get from molecules to moles, divide by Avogadro's number, and we're going to get 5 times 10 to the negative 24 moles. Again, that's not negative moles, but we're only working with 3 molecules. So it is a very, 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 very small part of the mole, being 6.02 times 10 to the 23. Okay, so it's not negative particles. We can't have negative particles. All right, so let's convert through our molar ratio. Oops, I got myself there. Put it back. All right, times 3 CO2s to every 1 propane. All right, so take our number of moles times 3 divided by 1, and we're going to get 1.5 times 10 to the negative 23 moles now of our required CO2. And then let's get back to particles since that's what they want. We're going to multiply this time by Avogadro's number, and we're going to get 9 molecules of CO2. And we are done. You can do your therefore statement. Therefore, 3 molecules of propane will react with with oxygen to produce 9 molecules of CO2. Now, if you are feeling really confident in your stoichiometry and in your understanding of what all these numbers really mean in the balanced chemical equation, you will notice there is a shortcut, all right, for this particular problem. You can go molecules, stop by to do the multiplication by the balanced ratio there, and then get to particles